Hello and welcome back to my Typescript series in which I show you how to write a lazy loader library. And in the last videos we've set up the project and then also implemented the first rough structure. In addition to that, we also created a demo page which we're going to use to do the lazy loading. I explained how lazy loading should work in general by providing a source, just a placeholder image, and then using the data source, which we see here, as the real source. And I just roughly explained what the process of lazy loading will be, namely replacing the source here, this transparent image, with the actual data source. And this is what we're going to do now. So in this tutorial, we're going to learn how to write modular code, talk a bit about single responsibility principles. I also show you how to write and use promises for lazy loading. And we'll actually implement what we want to do here, this load element 0, loading the first image or also other images. So this is the first logic we want to implement. So we have the interface here with this load element function. We have the component, and currently this just throws an exception because we didn't implement it yet. That's our task now. So first things first, we're using Typescript within our library to ensure that the types we pass around fit together and we don't need to do any type checks, which are quite common if you write JavaScript code and want to make sure that a certain input is of a certain type. Well, here this interface, which is called right here from the HTML page, here we could pass in, or let's look at this here, this is a string. We could basically pass in anything and the browser wouldn't throw an error. It wouldn't tell us. So the user will not know if what he passes in here is right or wrong. And that's basically because this is the boundary between normal JavaScript code and then our TypeScript code, which we're going to use from inside of this function. So this interface, it's a good idea to do an initial check, and if the input values are of the wrong type, throw an explicit error so the user of the library knows exactly what's wrong. So although we're inside of TypeScript here, we will do a type check, so type of element selector. So we check if the type of it is not equals a string, which is what we expect here on the TypeScript side. Then we're going to throw an error. And we're going to make this as explicit as possible so the user of the library knows instantly what he needs to change. So I just write, okay, create lazy loader error. The first argument, name element selector, has to be of type string. Now, if we're going to build the library again, and up here in the HTML, instead of passing in a string, let's just pass a number. If we now go to the example page, press F5, we're gonna get this error here. Create lazy loader error. First argument, element selector, has to be of type string. So as a user of the library, I know instantly, okay, what did I do here? The create lazy loader, I passed in a number, should be a string. I can change it back or change it to the correct type. Also, this maybe tells me I should read the README of the library, which explains what it expects. And now we're not gonna get this exception. We now end up with the exception we had in the first video inside of the library, where we now want to start implementing the actual load element. And that's quite an important concept in my opinion, making sure that at the boundary between your JavaScript or the calling code and your actual library, you make sure that the types are checked. Otherwise, your library might throw an error much further down where suddenly the type does not fit, and this error might not be as helpful for the user as if you would check right at the beginning. And I also extend those checks later when I define actual config. Okay, now what do we need to do? Let's just first write some comments here just to sum it up. First of all, when we want to load an element, we first need to know which elements are available. So first thing is what we need is we need to query the selector which was passed in. So query images selector, which will give us an array of all the elements, so all the images that are specified by that selector. Now the second thing we need to do is in load element, we need to check if the index is valid. So if it's inside the range from 0 to the number of selectors. Then we need to load the element, and as I said before, this will be an asynchronous process. So first thing, this method alone will not cut it here. We need some kind of constructor where we pass in all the images or the selector. And yeah, this is now part of what I was talking about in the beginning, modular coding and single responsibility. Now we have this lazy loader, and we could now start passing in the selector string, and now the lazy loader would do the query of the selector, the creation of the array. Then later it would check if here in this load element the index is valid, and then it would also create the promise and do the actual loading. But this is many things, so it's not just one responsibility. Now it has like 3 responsibilities. So the core functionality of the lazy loader is just making sure that a certain element is loaded and that it's a valid index. And all the other logic, so 1 and 3, should be handled by a different entity. So let's for now comment out this constructor and think about how we could split it. First of all, load the element. This already contains a bit of the information. So we're dealing with elements, and those elements are DOM elements. But what we could do, we could create a class here or a component which represents the element and what we want to do with it, namely loading it. So what I'm gonna do here, I'll create a new component which I call element loader. And it will be a class again, and in it I'm gonna put all the logic just for loading an element. So this is just for one element. Now with this element loader, what we can now do here in the element loader and the constructor, it will actually get an array of element loaders. And we just call this elements or element loaders. Now we need to save this, and now this is another concept of TypeScript. We actually have access modifiers here, so we can make a private variable, and same as for JavaScript, I use this convention where I say, okay, a private variable starts with an underscore, and I also later explain why this is important, because we can use it for mangling variables with our code minification. But for now, let's just define this element loaders array, and also I say, okay, that's the array of element loaders, and yeah, here I just assign it. Okay, so now this query of the image selector, we need to do it somewhere else, because this is what we need to do to create those element loaders. So let's go into this index here, and for now, here already you see the squiggly lines that tells us here we're missing an argument. Let's just create a helper function for now, and here later we can put this into a proper class. But for now, we're gonna create a local function here and just call this create element loaders. What it takes is the element selector, which is a string. We already checked that, and it will return an array of element loaders. Now what we need to do here to use this selector, we need to use some functionality to access the DOM or query the DOM, and for this I have actually a library available. So typically in the past you would be using jQuery for that, because back then or back in the times the browsers were not very compatible, so each browser had its own set of functions which were implemented already. So jQuery was used a lot to create this layer in between where all this compatibility was handled. Nowadays, most modern browsers implement all those basic functionality which we need here, so we don't need to burden us with using jQuery. But still, instead of spreading all those browser queries and functions across each library you're writing, what I thought was it would be a good idea to still write such a layer to access the browser in a consistent way. So in case later there are changes or certain functions are replaced by more modern or more efficient functions, all I need to do is change this implementation in the library, and I don't need to go into all the other dependent libraries and change all the cores of it. So if you go to my GitHub, you'll find this here, this MeBrite DOM tools, which is the library I was talking about. And yeah, it's very simple. If you look at the index, you see it's just exporting a lot of functions which just call directly some DOM functionality, so inserting stuff and also curing stuff, adding CSS classes, so all the stuff I typically need to write my libraries. And yeah, this little interface makes it easy later to make updates, improvements and stuff like that. So we're gonna use this, and I want to show you now how you can use NPM to directly access repositories on Git, which is how I use this MeBrite DOM tools from all my other libraries. So they kind of depend on it, but I don't have pushed this to NPM itself. I just host it here on my GitHub, and I can actually directly install it as I would an NPM package, just that I use the GitHub URL of that package. So as usual, I do npm I, and this time it's a real dependency, not just a dev dependency. So I can just directly here reference my GitHub. So GitHub, then Michael Breitung / MeBrite DOM tools. So this is my username on GitHub, and this is the name of the repository. What I could even do here by inserting a hash, I could now directly reference a commit. So commits in Git are represented by hashes, so unique hashes, and I could put them here. What I could also do, I could put a branch or a tag here. But if I just install it like this, every time I later run npm update, it will also update to the latest version, which is on my GitHub. So if I do updates to the DOM tools, I can later simply run npm update to get the latest version in this library. So if you now look at package.json, you see here under dependencies, I have the DOM tools, and I can now use them. And yeah, one function I want to use is a function to query the selectors or get back a list of all the nodes in the DOM that represent the selector. Well, let's get back to the index, to our helper function here. And I can now use the DOM tools to get all the HTML elements for the selector which I passed in. And here you see this DOM tools, again squiggly lines, but I can just import it because it was now installed. So let's just import the DOM tools from MeBrite DOM tools. And this is actually a named export from that library, so I have to import it as such. And now let me quickly explain what it does. So the function is called getElements, and here you also see, since it also uses TypeScript, I get this information. Okay, it takes a selector, which is a string, so our element selector, and it returns a node list of. And yeah, this node list of, we want to now convert it into an array, because this is what we want to pass down to the lazy loaders. So let's just create a simple for loop over this node list and put the contents into an array. So I want to create an array of element loaders, and I want to later return it. And then what I can do, and we'll leave this line here empty now, this logic will follow in a second, but what we can do now here, we can call this create element loaders. So let's say const element loaders equals create element loaders. We pass in the element selector, and then we can pass it to the element loader. And yeah, now everything should compile, although currently this elements array is still empty, so we need to push it in. How are we going to do that? So here this array takes element loaders, so we need to construct those element loaders from those HTML elements. So what I want to have is that the element loader in its constructor basically gets the HTML element it represents as an input. And again, we're going to save it as a private variable here. And I actually wrote this the wrong way around. So if you're writing code in other languages, you know, typically the type comes before the element. So sometimes I mix it up. And here I have a typo. Okay, so now I have this constructor which takes the element. This element loader doesn't do anything else yet. That's okay for now. We just want to finish the logic around it. So let's get back here. Now we do elements.push, new element loader, and this one takes the HTML elements at the index I. Okay, so now the logic of gaining access to the DOM elements, then creating element loaders for each of those elements, returning this as an array and passing it to the lazy loader is finished. Now let's go back to the lazy loader TS, where we now have a set of element loaders. Now if we call load element, we can now implement the logic here, although we don't yet have any logic inside the element loader, but we can do what I explained we need to do here. We need to check if the index is bigger than 0 and also inside the range of available loaders. So this dot element loader dot length, and only then will we load the item. Otherwise, we're gonna throw an error, which is explicit and tells the user what's happening. So you already know this process, throw new error, and I'm gonna tell it we're inside the lazy loader, inside the function load elements or load element, and we have an error, invalid index, and we're also gonna tell it what the index is. Now what we see here is the squiggly lines telling us, okay, currently we don't actually return a promise yet, and yeah, we don't want to return it here or construct it here. What we want to do is now to call a function in the element loader, which we now have to implement. So I call this function load, and it doesn't get any parameter because it knows what to load. It has to load the element, but it will return the same promise which the lazy loader returns. So this is what we're going to do here. So currently we have the error here, we need to implement it. So how do we return a promise, or how do we create a promise? So we want to return a new promise. So promise is a class which is provided by JavaScript already. And if we hover over it, it tells us what it expects in the constructor. So actually it expects an executor, which is a function, and this function returns as a first parameter this resolve here, which again is a function. So first parameter is the resolve function, the second parameter is the reject function. And yeah, let's just do this. So let's pass it a function, resolve as first, reject as second. And for now, what we're gonna do is just resolve the promise. So right away, we don't do anything with it. So that's the typical way you write a promise. So you use the constructor for the promise. This then expects a callback function to which it will pass the resolve and the reject functions. And those you have to call at a specific time. For example, what we're gonna do later when we load the image. Once the loading is finished, we will call the resolve. And if anything goes wrong, we will call the reject. And actually here we say we return a promise that includes a boolean. So let's just also pass this boolean. And yeah, currently there's no logic yet. So this promise will be directly resolved, but at least we've satisfied the compiler here. So let's go back to the loader. And what we're going to do here now, this dot element loader dot or not dot, we have to now access the correct loader and call load. And since this returns a promise, what we can do here is just return whatever this load function returns. And also let me quickly rename this, because element loader, it's actually element loaders. So Control-Shift-L to rename all instances here. So this is a little better now. So also I can now remove 3 because we now do this inside of this element loaders load function. So the only thing here inside of the lazy loader now is ensuring that the index is valid and then calling the load function on the correct element loader. And later there will also be a little bit more logic here, but for now it's very simple. So it just has a very small responsibility here. Let's go back to the element loader now. Here you see we currently directly resolve the promise, which is not what we want to do. What we want to do is we only want to resolve it once the image is loaded. And for this we can now register a callback for the onload event that is called for this element, the image element, once it's loaded. So what we can do here is this dot element dot onload. So I basically override the onload callback, and this will be a function in which I'm gonna resolve the promise. And we will do a bit more here later, but for now this is just telling us image is loaded. So what we will do, we will use another function from the DOM tools, and I just paste it in here. And also let's import the DOM tools. Within the DOM tools there's a method called getAttribute, and what this does, it queries the attribute. In this case I called here a constant, which we're going to define from the elements. So the data source attribute, let's just define this const up here, is basically the string for the data source here. So this string, this is an attribute here, data title, this is an attribute here, data source, and also the source is also an attribute, as well as the width and the height. So you can get access to those attributes by using my DOM tools. And if you want to know what the exact function is that is called, you can just have a look at my GitHub. But for the DOM tools, it's just getAttribute. So now here we have access to the data source. Now what we want to do, we want to use this data source and set it for the actual source. And there's another function in the DOM tools which is called setAttribute. And here again, let's just define this const. So here we have some squiggly lines, so let's have a look here. What does it tell me? It tells me that I'm not allowed to set this argument here because it could either be a string or null. So let's look again at this getAttributes. So what if the attribute data source does not exist? Then this attribute will return null. This is what the function here tells me. It can return a string or a null. And if we look down here at the tsconfig, I've set it up to do strict null checks, which I think is a very important setting. This helps you to avoid anything being passed around and used while it's still null. So sometimes you have functions which return undefined or null, and Visual Studio Code will check this here. And also you can specify this for functions. So this means that I have to check if this data source actually exists. Data source not equals null, then I can set the attribute. And we'll later do a little more intricate logic here to make sure that the data source exists before we even get into this logic. But for now, if the data source exists, we set the attribute. And when we set this attribute, the loading of the image will be triggered. And once it's loaded, we'll end up here. And what we're now gonna do here, we will remove the data source attribute. And now you also see why I define consts up here, because this way also I don't have any duplication of the strings. I just use the same const here. So now the process can be described very simply. So I get into this load function. I check if there's a data source attribute. If there is, I set it as the new source attribute. Browser will start downloading the image, and once it's loaded, this onload handler will be called. I remove the data source attribute and I resolve the promise. So what should we do up here for the else? So if there is no data source attribute, here we can use the reject method now, reject. And what should we pass as the boolean? We'll pass a true here. And now you'll see why I have a promise here, which also includes a boolean. So this boolean is basically telling if the image is loaded. So if the promise is resolved, with true, it says, okay, everything went fine and the image is loaded. And down here, we now in this else have a reject, but still tell it the image is loaded because there is no longer a data source. So the image was already loaded. Because currently we don't check if you call load multiple times on an image. So if you load an image and later load it again, the data source will be gone because we remove it here, but the image is still loaded. So we reject this call because the load call wasn't executed, but here we tell the caller still the image is loaded. And as I said, this logic will get a little bit more intricate, but for now we can leave it like that, very simple. And I think now it's time to actually give this a try. So let's rebuild it, npm run build, and then head over to the test page and rerun it. And you see Oh, I have actually an uncaught error, lazy loader load element, invalid index. Let's see, what did I do? We're here, invalid. Oh yeah, I have a bigger 0, so it needs to be bigger equals 0 because 0 is also a valid index. So yeah, that was my mistake. Now let's build it again. Head back to the page and refresh. And you see, voila, here's the first image, but only the first one. Now let's do a network simulation again. And now have a close look down here at the loading. You see here the first image is loaded and then it appears. There's one more thing I need to do, because currently what I've written up here in the lazy HTML is not 100% correct, because directly when we get down here to the script tag, we directly start executing the create lazy loader and curing selectors and everything. This is only fine if the complete DOM is properly loaded. And while the DOM should be in place because we have those scripts here at the end, to be on the safe side, it's a good idea to wrap such code here, which depends on the structure of the DOM being intact because it makes queries and changes to it, to wrap this into a window onload event. So what we're going to do here, we will register a load event listener for the window. So here we are directly using the API for the browser. And this function is a little different to just what we did here in the loader, where we just said, okay, this element on load, we will call this function here. This basically overrides the onload, so you can only have this one callback. What we do here, we register an event listener. So you could have multiple event listeners registered for this window onload, and this makes sense because you might have multiple libraries doing this. And in it we then start to create the library and load the first element. So if you're familiar with jQuery, you know there's this document ready handler, which is a little different to what we're doing here. So this load event handler is executed once the complete DOM is there and also the resources are loaded. So sometimes you might want to have your code start executing earlier, but for my use cases where I do visual changes to the DOM and stuff like that, like lazy loading, it's totally fine to have this load handler registered here, which might be executed a little later than some other handlers, but it's totally fine. I just want to make sure that the DOM is completely intact and also everything else is loaded. Then I start loading the images. Now let's double check this also. Refresh the page and you see there was a little pending down here. It took a little longer and then the image is loaded. Now let's also load another image. Let's load the third image. And now I scroll down a bit because the third image will be further down. Here it is. So index number 3 is actually the fourth image. And also if we look down here and inspect the DOM inside the container where we have all those images, you now see here those first images. Here we still have the transparent image, here we have it, here we have it, but down here this image number 4, which we just loaded, it has now the source, the actual image, and the data source is also gone. So yeah, this is basically how lazy loading works, and there will be another video where we're gonna extend the logic a bit. This is very simple, and also there's nothing yet about this scroll loading I was talking about in the first video. So currently it's just a very stupid library which you have to manually control, tell it which elements to load. But what we also want to have is some window around this element. So you might think about if you have a slideshow like I have on my homepage. If you load a specific image, for example here in the middle, and I would just always load this image, and now the user goes to the next image, it would then start loading the next image lazily. There would be a delay. So for proper loading mechanism, what's best is you have some windowed loading. For example, what I've implemented here, if I select this image, it will not only load this image, it will also load 3 images into this direction and 5 images into this direction. So basically all the images you have down here also around this one can be loaded. So yeah, this is one nice mechanism you can implement, and which I also gonna show you how to do, basically a windowed loading. And then also we're gonna look at the scroll loading, which not only works for images, but also, as you can see here, for YouTube tutorials. But since this video is already dragging on for quite some time, we're gonna stop it here. I hope you liked it. Make sure to subscribe for the follow-up videos. Also, please give it a like and yeah, spread the word if you like this channel, and see you in the next video. Bye.